Morning, everyone. My name is Timothy Lee Grant, and one of the things that I've realized is a lot of the stuff that I learned in school didn't actually teach me the skills for software engineering that I need. So I decided that I'm going to try to do a YouTube series where I'm learning all of the things that I think are important within software engineering, all of those skills that are important for me to become a even reasonable developer because right now, what I learned in school is so completely different than what I actually need. And the more that I'm learning about what actual software engineering is, the more I'm realizing, like, oh, uh-oh, I'm in trouble. So, right now, I am a firmware engineer, which is more hardware based, but I'm hoping to be able to get into the development, software development space. So, the two skills are very apart from each other. So that's what this series is about. And in the last video that I made about software engineering fundamentals, I heard about this thing called a design pattern. I had never heard about it before. I didn't really know what it was, but I heard people talking about it. And I was like, okay, what is it? What does that do? And so I went to GPT and let me make myself a little bit smaller. I went to GPT and it gave me a lot more than what I was expecting. So I was expecting that it was going to be something really simple and I would be able to kind of like understand it quickly and that was going to be the video. But instead, it gave me Singleton, factory method, adapter, composite, observer, strategy, right? Like it gave me a whole bunch of uh, different patterns, and I spent the duration of the last video kind of going through each one of those six that it gave me. But I didn't spend time going in depth into each pattern. And so that's what I am planning on doing now is okay, cool. We saw, I guess, a high level overview of what the patterns are. Now I am going to try to dedicate one video to each of these different types of patterns and try to understand like what's actually going on, what's happening here. So today's video is going to be about this singleton. So let's copy this and let's say here is what you showed me for the singleton. It's not spelled right. Singleton pattern. Can you tell me more about this pattern? That would be kind of funny though if it just said like no. Like, I want to learn more. Can you tell me more? No. Okay, anyways. It didn't say no, it said absolutely. All right, so the singleton pattern is one of the most popular creational pattern or design patterns. Okay, so I remember last time these are a whole bunch of leak code stuff, but okay, that's leak code still. I remember it was telling me, yeah, here we have creational patterns, we have structural patterns, and we have behavioral patterns. So there's three different categories of these patterns that it told me about. So singleton is here, it is part of the creational patterns. So I guess before I start, I should kind of reread these two sentences. So, all right, creational patterns. These deal with object creation mechanisms, trying to create objects in a manner suitable to the situation. So, creational patterns are, as the name might imply, you're creating objects, okay? So, singleton here ensures a class has only one instance and provides a global point of access to it. Okay, so what I'm going to guess is going to be the case is that the singleton is some way for me to ensure and force a class to only have a single instance of itself, so I can't create multiple objects from one class. I can only have one object. And then something about a global point of access to it. So let's go back to what I was asking. All right, so I just gave it the code that it gave to me for what a singleton is and said, "Can you ask or can you tell me more about it?" So, absolutely. The singleton pattern is one of the most popular creational design patterns. Its primary purpose is to ensure that a class has only one instance and provides a global point of access to that instance. Okay, so that's kind of what it was telling me above. So that's not very new information. Let's continue to go into more of the detail. All right, so key characteristics of singleton pattern. Single instance. It restricts the instantiation of a class to one single instance. Okay, so we can't create multiple instances. This ensures that there is only one instance of the class throughout the lifetime of the application. All right. Global access point. It provides a global access point to that instance, meaning you can access the single instance from anywhere in the code. Okay, so I guess that means that I don't need to just get it from one. And this actually does bring up a secondary question, which is when I have a large scale software program, or what was the specific word that they used? I think application. Okay, so if I have a large scale application, and again, in school, you only had one file. You had like your main file, and this main file would perform the actions that you needed, right? Like if it was a networking class, it would perform the operations to do the homework assignment. If it was a machine learning class, it would be, I don't know, implementing backwards propagation for a neural network or the gradient descent or whatever it is, right? Like you have one file, there it is, and it's doing its one thing. And that one thing is kind of proving that you understand the material in the class. Now, software development, you have 30, 40, 50 files all like interwoven together, making up one application. And how do those interact with each other? How do you, where is one thing valid and the other one is not? And how do you organize the architecture of these separate files, which is also object-oriented programming, none of which I know right now, but all of which I'm hoping to be able to get more familiarity and understand more through these videos. This is why I'm doing these videos, because right now I recognize the fact that I don't really know what I should to become a software developer, to become an actual software engineer. So, just kind of talking out loud, saying all of those things that I am recognizing. So there's the observational stage, right? Like I'm observing and I say, okay, cool. I see that there's a problem here. I don't understand something here. Second thing is I've observed that I don't understand something here. The second part is what is that something? Kind of defining it. Then once I've defined it, then move forward and actually try to make progress understanding it. So observing it, trying to define it, and then understanding it. But we're going to continue with Singleton right now. That's this video. So, but that's something on the horizon. That's something we will be doing in the future. Learning all of those software so, what did I call it? Like software engineering fundamentals. I think this video is, or this series is called. Okay, so second key characteristic of a singleton pattern is global access point. It provides a global access point to that instance of the class, meaning you meaning you can access the single instance from anywhere in the code. So I think that this means that no matter which file I'm in, I'm able to just like get that uh, get that object. Okay. Lazy initialization. Oh, okay. What's this? The singleton instance is created only when it is needed, which is often termed as lazy instantiation. Okay, so we're not just going to instantiate the object if we don't need it. So I think that the advantage to this would be you save a lot of memory. If the object is very big, and then let's say you don't even need the object, or let's say that there's 1,000 objects, each of which are big, but you're only going to use 5 of them. So with this lazy instantiation, I'm only going to instantiate the 5 of them, and the other 1,000 or 995 other classes are not going to be initialized. They're not going to use up any memory. So I can see that's definitely a good and big advantage. Okay, cool. When to use singleton pattern. Configuration settings. When you want to manage a global configuration in your application. Okay, so I can see how that would be useful. So the way that I normally deal with settings right now is that I have some kind of like global parameters, like whatever, baud rate or uh, size, or right, like I have these variables and they're a single variable, and I just have them as a const and then the name of the variable and then set it equal to something, and that's going to live through the duration of my the program's execution. So that's how I kind of do it with the embedded systems stuff. But this is a class, right? So it's not a single variable that I just have const. It is now a class representing configuration settings. I think that's what this one is talking about. So we're going to go through these. We're eventually going to get to uh, Visual Studio and actually code some stuff up. But first we need to get the theory behind us, and then we can move on to the coding. So, all right. Logging. To create a single instance of a log manager to handle the logging functionality across the application. What does that mean? I'm not exactly sure, so let's look at it. To create a single instance of a logger or of a log manager to handle the logging functionality across the application. So is this kind of like an interface with hardware? Or am I thinking way too... Because the way that I'm thinking about this would be it is an like an API that I'm able to call that directly interacts with the hardware and logs things to the console or whatever. Not sure if that's what it's actually meaning. Not sure. Okay, resource management. When you need to control access to a resource like database connections. Okay, so a lot of this has to do, I can see how they're trying to say, like, okay, we want a single point of access and we don't want multiple different structures or locations where settings are stored or where access to a database is, you're able to make calls to a database. We want a single point. And so Singleton allows you to create that single instance, and I guess it enforces that singleness. Okay. Now we're going to go to benefits, drawbacks, and then finally start looking at code. All right. Benefits. Controlled access to the single instance. It provides a way to access the single instance in a controlled manner. Okay, that's kind of what we've been talking about. Reduced memory footprint. Only one instance of the class is created, reducing memory consumption. Okay, that's also something that we talked about. Easy to maintain. All modifications to the instance are centralized. Yep, that's one location, so you're not going to have to change it in multiple different places. Makes sense? Drawbacks is global state. So singletons introduce a global state to the application, which might make debugging and testing harder. Sure. Concurrency issues. In a multi-threaded environment, you need to ensure that the singleton instance creation is thread safe. So trying... So if we're running multiple threads, trying to think of how this would fail under multi-threading. The only thing that I could think of is just if one thread is setting a variable to be one thing, but then another thread is setting the variable to be another thing. I mean, is that really a race condition? Not sure. Okay, but that's what it's saying, is that concurrency issues can be a problem. All right, so import thread. Oh, well, it's going to give us a multi-threaded. I don't want to use the word instance because that's a keyword within object-oriented programming, but it is going to give us a multi-threaded example. There we go, example. So let's look at it. Import threading. Class singleton. Instance none. Lock. Threading.lock. Okay. Right now I'm just trying to get a look at this class and then dig into a little bit more of like what's actually going on and how are these fields interacting with each other. So I have these two variables, which is instance, and it's first set to none. Then I'm getting a lock, which this lock is an instantiation of the threading lock. So I'm just calling this and getting a lock object. Okay. Then I have a method which is dunder new. Now a question I have is, what is this dunder new and what is this CLS? Okay. So I'm going to be asking, that's going to be a follow-up question, is what is dunder new and what is CLS? So now we say with. Again, here's another thing. I've never seen the keyword with in Python, so I don't even know what that does. Very glad that I was able to happen upon it just now, because whenever I see something that I don't know, it is a wonderful opportunity for me to fill in gaps in my knowledge. So, what is with? I have no idea, but I'm going to figure it out. All right. So, with CRS, which again, CLS, so I don't really know what that is, but that's passed in as a parameter. And then dot lock. Okay. Now I say CLS instance. So I'm checking if the instance is none. And I'm noticing that this CLS has both member variables lock and instance. So I'm thinking that CLS is like a reference to self, maybe? I don't know. So I see if instance is equal to none. If it is, I do this. Okay. If it's not, I don't initialize. Okay. Okay, I think I see what's kind of happening. So this CLS instance is initially going to be set to none, right? And then if it is set to none, then I can change this instance to be something. Okay? It's something. I don't know what this is going to be doing right now, but it's going to do something. And then it's going to set this instance to be something. Now, if I try to do another instantiation, it's going to come here and it's going to say, oh, instance is already something. Therefore, I'm just going to continue to return the old thing. I think that's what's happening. Okay. Super Singleton CLS. Okay. I have a few questions about this. What is new function? Is this a built-in function? What is CLS? Okay. What is the with keyword? And what is going on in the line? Okay, so there's a lot of questions, but that's good. That means that there's a lot of learning. So let's throw that up. And while that's doing its thing, I'm going to take a sip of coffee. All right. So, the new function. Definition. New is a special method in Python that is responsible for new instances of a class. It is called before the init method. So built-in function, yes, it is a built-in function. Okay. Purpose, it allows you to control the creation of a new instance, which is why it is useful in the singleton pattern. So what's the difference between new and init? Okay. Possibly a follow-up question, right? CLS is a convention for the first parameter of class methods. Oh, class. CLS, class, okay? It represents the class itself, similar to how self represents the instance of a class, okay? So that implies that implies that when I'm doing those operations, I'm doing the operation on the class and not the object. How's that possible? Okay. It represents the class itself. Usage. In the new method, CLS is used to refer to the class being instantiated. So this new here, this new dunder method is a way for us. So when I call an object, okay, so I have a class, okay, I have a class, and when I call this class, this new is evoked, not the init, right? And normally it's just an init. So here's yeah, this is going to have to be a follow-up question because I'm going to try to have to figure out like what actually happens during instantiation. Because apparently I don't have a very good grasp of what actually occurs during instantiation of a class. Okay, so with keyword. The with keyword is used to wrap the execution of a block of code within methods defined by a context manager. What? What? Okay. Uh Context managers help to properly manage resources, ensuring that they are cleaned up properly, okay? In the Singleton example, with is used to acquire and release a lock to ensure thread safe access to the Singleton instance. I'm not quite I'm not quite on board with this with. Are you guys? How are we feeling with this with? I'm shaky. I don't know how I'm feeling about that. All right. Number 4. So now I'm asking about this line with all of that super and because I know super has to do with like inheritance, right? And I'm doing super, but Singleton doesn't have any parent class. So how are we doing that? That doesn't make any sense. Super and then Singleton, the class itself. Then we're calling new like that doesn't make any sense. I don't see what's happening there. Okay. So purpose. This line creates the new instance of a Singleton class. So again, is that implying that I think that there's a misunderstanding that I'm having with class and object because I thought that this entire class was going to be instantiated when I called this right here, right? But I guess not. It gets instantiated at this line of code. So I do this here, and then it comes and does this new. It checks if it has the lock, maybe. I don't know what that one does. Anyways, here I see if I've already created an instance. If I have not, then this is where I actually instantiate it. And so apparently but then this seems like recursion, right? Because I'm doing now new, so I'm calling this here, and then it's going to come down and do it again, and do it again, and do it again, and do it again. Uh, oh. Okay. This line creates the new instance of a singleton class. Super singleton CLS. This returns a proxy object. A proxy object? What's proxy object, Precious? What? A proxy object that delineates method calls to a parent or sibling class of CLS. What? In this case, it delegates to the base object class. I don't know. Sure. What? Okay. New. CLS. New, and then passing in class. This actually creates a new instance of the CLS class. Or a new instance of the class. And then it's assigned to CLS instance. Hold on a second. Okay. Okay. Maybe take a little bit more coffee. I don't know. I'm really trying to understand what's happening here, but I feel like there's a lot of gaps in my knowledge right now, and I don't even know where to begin. And this is kind of a theme that I'm noticing with software engineering and software development is that it's such a vast amount of stuff that I have no idea about. Where do you even start? How do you actually make progress? Honestly, the task right now seems overwhelming and daunting. That there's just so much that I need to learn. There's so much that I don't know. And how do I actually start learning these skills? Here's a step-by-step breakdown of the process. If CLS instance is none, check if an instance of the singleton class already exists. So how does it know if an instance already exists? How does it have that knowledge? Because it's just a class. I can instantiate it twice, right? It does. I don't see how it enforces, or how let's say I instantiate it once. Okay, cool. I I do here. I do this. I do the instantiation once. Okay, great. Now I come here. I do the second instantiation. I don't see how. Okay, here, and now I'm coming here. How does it have knowledge of a different class that maybe that is actually what's going on with this class, that I'm changing this singleton class itself. So singleton. So maybe it is, let me just run this, right? Where's the run here? No. There we go. So true. Okay, cool. So we're just printing if these are equal to each other. Okay, so move myself back up here. All right. So how does, when I do this second one, maybe I am changing the class itself. So now when I run this, I no longer have this none, but I'm not changing the object. I'm not changing the singleton one. I am changing the the blueprint itself to be something, right? Like whatever that is. It is something now. And so this, okay, I think I see kind of what's going on. I think what's happening is I'm actually changing the class itself, and because I'm changing the class itself, I come here, I get this singleton. Let's see. Let's see. Uh, my variable equals what do we want to say? 5 4 I 2 J5. Okay, it's just a random number. So I'm putting this here. And now I am going to try to do like singleton1 dot my var equals gotcha. So we changed it, right? And now I am going to print singleton2 dot my var. Okay, I want to see if it's going to print this 5-4 or if it's going to print the gotcha. Okay, let's run it and see what happens. I'm guess gotcha. Oh, it changed. So it did. Okay, so I think I'm on the right track. So okay. So these two things are the exact same object. Okay. Now I'm starting to understand. I think I understand this a little bit more. When I can make one change to one object, and it's almost like doing like singleton 1, whoops, singleton 1 equals singleton 2. So you're just setting them equal to each other. So when you do one change, it affects the other one. Now, trying to understand, like, so now this thing is talking, it manipulates the class itself, not not the specific instance. Now I'm starting to see why we do that. So we come here. I'm going to delete all of this stuff, so that's not kind of relevant. Okay. So we come here and we now start this new, because that's the instantiation. It's the first instantiation. Okay, so we do this new. Then we have the with lock. Okay, whatever. I don't care about that right now. So now I say with cls.instance, or if cls instance is none. Now, is cls instance none? As of right now, it is, because look, cls instance is none. Okay? So then what we do is we come here and we do cls instance, and this right here is acting on the class itself. So that's kind of like saying this. So we're changing the class itself. We're not pasting, but like putting that up there. And now when we call it, well, is that true? When we call it a second time, so this thing is going to return something, and it's going to be an object. And now this object is going to be this, whatever this thing like returned. So I'm just getting that object, and let's say that this returns what I said, something, right? So this returns something, and we set this here. So now we've changed instance, the actual blueprint, not the object, the blueprint, to be something. So now it's not going to run this line the second time we call right here. Okay, and then we just return the actual instance. So that's why both of them are referring to this something object, because this something object, this is where the object actually gets instantiated. Right here, and we said that it returns something, and then we set that something to this instance. Okay, I'm starting to kind of see how it's working, but I'm at like a 20% right now. I'm not even at a 50%. I'm at a 20%. I'm just talking through, trying to okay. So we have none here. Okay. So I'm still trying to I'm going to figure out what this line does, because I don't know what on earth a proxy, all of that weird language that I haven't heard of. What did they call it? Proxy object, yeah. I have no idea what you are meaning here. Could you explain this more? Okay. All right, so super. The super function is used to give you access to methods and properties of a parent or sibling class. But I don't have a parent. Right? This singleton has no parent. Okay. Super singleton class. Singleton is the class where super is being called. Singleton is the class. Singleton is the class where super is being called. Singleton itself is the class where this is the class currently being instantiated. What? By using super Singleton class, you're telling Python, I want to get a proxy object. Here's that proxy object thing. Okay, it's talking about it down there. Good. I want to get a proxy object from the CLS class, but I want to look in the Singleton class's hierarchy to find the method I'm calling. Okay. I'm going to reread that again. By using super Singleton CLS, you are telling Python, I want to get a proxy object. So we're getting something. We are getting a proxy object for the CLS class. Okay? But I want it to look in the Singleton. So there's a hierarchy inside of Singleton to find the method that I'm calling. Okay. Oh my goodness. Proxy object. When you call super Singleton CLS, it returns a proxy object. This proxy object knows to look in the superclass or superclasses of a Singleton for the method new. I didn't really explain what a proxy object is, though. In the context of the Singleton pattern, super whatever, this line is used to ensure the creation of a Singleton instance is handled by the superclass, which in most cases is the object class in Python. Instance check. If the instance is none, it means no instance exists yet. Super call. Super Singleton calls the new method from the superclass. In this case, the base object class to create a new instance. Assigning instance. The newly created instance is then assigned to instance. Yeah. This ensures new is called correctly according to class hierarchy, even if Singleton is subclassed in the future. So see, parent right here, or child, inherits from parent. And now I can do super, child, and then self, and then call init, okay? But I don't have a parent class in Singleton. But in Singleton class, I don't have any parent class. How am I able to use super? Okay. And doesn't calling the dunder new from the dunder new cause recursion. Am I out of coffee? I have one more sip left. One more. Here we go. Okay. So, in a more digestible way. At first, I thought it said in the most digestible way. Let's simple the. I thought it was gonna say we have to really dumb it down for you. I was like, oh boy, okay, okay. No, in a more digestible way. There we are. The super function is used to give you access to methods and properties of a parent or sibling class. In simpler terms, it's a way to call methods from a parent. Okay, yes. Super singleton. So, okay, no, here. Great question. Let's clear up concepts. Parent and parent class and super. Even if it might not seem obvious, every class in Python implicitly inherits from the built-in object class. Okay, so there's this class called object, which is in Python, that every class inherits from, even if... Oh, I see. So it's like object here. I'm actually gonna try to do that. Let me see. Object. Oh, okay. It's keyworded. Go to definition. Oh, look at this. Wow. Oh my goodness. Cool. Oof, the sun's right in my eyes. But that's pretty cool. Okay, so what do we have here? Wow, look at all this. Look at this. Overloaders. Get and init and class method. What's this? Class static? No, we want object. Okay, so here's our init. Here's our new, oh my goodness, dot dot dot. And so it's returns self. This one returns none. Okay. But anyways, okay, so we found that. So this means that Singleton does not, or does have a parent class, which is object. Okay, so now we do this Singleton and we get this new. So we go to the new, right? We call this new and it returns itself. So it returns self and we just return that. So it's an object, okay? But then how do we have all of these other variables, right? Okay. So in this case, returns a proxy object that looks for the new method in the parent class object. So I look for that new, which is right here, and it calls that new, right? And new takes in CLS, okay, and returns itself. But what are these dot dot dots? Like, is there hidden code somewhere? I don't see any hidden code. When you call CL, I don't think we're gonna hit recursion because I thought that this dunder new was calling this dunder new, and we're just doing that. But this is actually calling the parent class's dunder new, so that wouldn't be recursion. It doesn't cause recursion because of how super works. Okay. So super singleton CLS, this specifically calls the new method from the parent object. Yeah, not the singleton class itself. Okay. No recursion. We're good. Okay. What? Okay. When I go to Python's object class, I see the following. Okay. Now I'm going to copy and paste this class here. Okay, so copy and paste this. Can you walk through exactly what happens when I what am I asking? I want to know, like, what's happening with this dunder new and the parent? Like, what when I call the line here. Okay. All right, so let's walk through what happens when you call that line. Step by step. So it returns I get that. I get that. No, I mean like I want to know how the parent class actually deals with the request. Okay. So, I want to know how this dunder new actually works because the way I'm seeing it, it says dunder new CLS returns itself and then three dots. Like I don't see what that does. It translates to calling the method of object. Okay, so when object new is called, it starts the process of creating a new object instance of the CLS, which Singleton in our case. Memory allocation. Okay, so memory allocation. The new object in the object class is responsible for allocating memory for the new instance. It allocates enough space in memory to hold all attributes of the instance. So I don't see where that code is though. It just says like CLS self. Like, am I missing something? Um, Here is the line of code in the object class. I don't see where any of that activity can take place. The line you're referring to here is a simplified representation of the new method in the object class. Okay, that's kind of what I was that there here we go. So there is missing code. Okay, awesome. It's a simplified. Where was I? The actual implementation of new in the object class is written in C as part of the Python interpreter, which is why you don't see the full. Oh, okay. Now, I know that I said that this video is going to be about the Singleton class, but I'm also a little bit curious, like, because that brings up a secondary question. Okay, so hold on. I didn't know that there was C code going on, so I'm guessing that the C code is written to implement the Python objects and calls, and so Python is written in C, possibly. And so, how does that work? Like, what is the base? Again, this is definitely not the purpose of this video. I'm just thinking, as I mentioned, like first identifying things that I don't understand, then defining it, then learning later. So Python is a language, okay? Yes. It is it has certain methods, or not methods. I don't want to use that word because method is a keyword, but it has certain keywords such as method and object, and it has all of these things. And so this, where was I? In the object class, this new must be written in C, right? So there is a class, or there's a C doesn't have classes. There is a function or block of code or something which will be called here. How, who, and what associates the two? Is that the linker? But Python is not compiled, so I don't think that there is a linker. So how does C and Python play together? How do they play together? That's an interesting question. But for right now, we kind of got the answer that we were, oh, that's sun. We kind of got the answer that we were looking for to understand the singleton method, is that this is a block of code that's going to run, and we see that it just returns an object or a self object. Okay. So now we get the self object. And I think it is an instantiation of this CLS class. Okay, so that's how that's working. Then when we call this, because we changed the instance itself, not the specific object, but the class itself, when we come here again, this instance, or this instance, here, is going to be set to an object. And it is which object? It is the previous object that we just instantiated. And then we just return that previous object that we just instantiated. That's why Singleton 1 and Singleton 2 are the same thing. And that's also why when I changed this my variable in Singleton 1, it changed the same variable in Singleton 2 because it is the same object. Here we go. I think we got I think we got it. This is pretty that was clever, clever, clever. What do you guys think of this singleton pattern? I like it. That's a pretty clever implementation that they got. We learned a lot about Python, a lot about how objects are working under the hood. I am very happy with today's episode. So, anyways, thank you guys so much for watching. If you enjoyed this video, subscribe. That would be amazing. What am I? I think I'm at 540 subscribers now. So, thank you to everyone who subscribed. And in the future, I am going to be creating more of these software engineering fundamental videos. I have a lot to go over. So we just did this singleton. Next time, we're going to be doing this factory. And I also do, let's see, so I'm going to be continuing these software engineering fundamentals. Once I finish all 6 of these patterns, I'm going to be continually looking for other skills that I think are important for software engineering and becoming a good software developer. So that's number 1. Number 2, I do leak coding every single day, trying to build my skills, maintain my skills, and get a wide array of different kinds of leak coding problems. So that's number 2. Third one is I do Java and JavaScript videos. So learning not just the language, but kind of the domain which they live in. Specifically with JavaScript, all of the client server interactions, how to process requests, middleware functions, how web development, because as I said, like my degree is electrical and computer engineering. So most of the stuff that I learned was a lot of the low level embedded systems, hardware, all that kind of stuff. So I didn't get a lot of that web development and mobile development and server commu- communication backend processes. So that's kind of what I'm trying to do with my JavaScript videos. And then the other series that I want to start really soon is going to be open source. So the last time that I attempted to do open source, I got pretty confused because there were so many files. I didn't understand what was going on, and I was just like, what? And so I'm hoping to be able to kind of restart, I don't know, just looking at open source, trying to understand how all of those files are acting together. And I think that an open source series will be extremely beneficial to me and showcase a lot of those software engineering fundamentals that I'm missing right now. So, kind of the software engineering fundamentals, this series right here, plus the open source series, I think are going to really mesh together in a very harmonic way. So, I'm hoping to be able to start doing the open source. I don't know what I'm going to be looking at or which open source project I'm going to be looking at, but that's kind of just like doing a series looking into how do you even start? Like, I have no idea, but that's what I'm hoping to do. So if any of this seems interesting, subscribe, and I will. Um, I'll love to go on this journey together. So, anyways, thank you guys for watching. My name is Timothy Lee Grant, and I will see you guys tomorrow.